Today we are going to do Kolbe's electrolysis, that is a method of decarboxylation of carboxylic acid, that is the removal of COOH group from carboxylic acid. So this is the general formula of carboxylic acid, and the removal of this is known as decarboxylation. Carbon is removed, decarboxylation. And Kolbe's electrolysis is an electrolytic method of decarboxylation, okay, in which we are going to do electrolysis of a metallic salt of carboxylic acid. Any metallic salt can be there, like sodium carboxylate or potassium carboxylate, or maybe sodium salt of carboxylic acid or potassium salt of carboxylic acid, whatever you want to state it, okay. So we're going to take sodium salt of carboxylic acid in its aqueous form, so H2 is there as well, and we're going to do the electrolysis of these both. So RCOONA after electrolysis will give us, okay, here should be a sign of reversibility. After electrolysis will give us RCOO negative plus Na positive, and here H2O will give H positive and OH negative. So we've got two anions and two cations, and you know we have anode positively charged and we have cathode negatively charged. Okay, so anode is positively charged. Any one of the two negatively charged ions or anions will go to the anode, give out its electron, undergoing oxidation, and then deposit itself on the anode. And any two of these positively charged ions or cations will go on the cathode, take one electron or the number of electrons required, and then reduce it themselves and then deposit on the cathode. Now we have to decide which of these will go in the anode and which of these will go on the cathode. So how to decide it? It should be done on the basis of electrode potential or reduction potential, whatever you want to say it. Electrode potential is a more good term or appropriate term, you may say. Okay, so yeah, so electrode potential, the species or ion or metal, whatever you want to say, having lesser value of electrode potential undergoes oxidation preferably, and having higher value of those having higher value of electrode potential preferably undergo reduction. So we are going to compare these two for oxidation in the anode, right? So the one having lesser value of electrode potential will undergo oxidation. So here carboxylate ion is having lesser value of electrode potential than OH hydroxyl ion, so it will undergo oxidation. Okay, and then for these two we will compare which one is having higher value of electrode potential, so that can preferably undergo reduction. So hydrogen H positive, it has higher value of electrode potential, so it will undergo reduction in cathode, okay, and not sodium. So okay, we're going to do, it's clear that we are going to perform oxidation of carboxylate ion and reduction of H positive ion. Okay, so oxidation of carboxylate ion, RCOON, oh sorry, N is not the right, carboxylate ion, yeah. So it will take one, it will give out one electron. See, one electron gone, and it will deposit itself there, right? And similarly for H positive, it will take one electron and form H2. So it is forming H2, so it requires 2 electrons, right? So it will take 2 electrons and form H2. So take 2 electrons, form H2, undergoing reduction, right? Now, you know that for electrolysis, the charge that is taken should be equal to the charge that is given out. So here should be 2 electrons. And if 2 electrons are given out, so there should be 2 ions of carboxylate, 2 carboxylate ions, and here should be 2 RCOO coming. Alright, so these are the equations we've got, these are the ionic equations we've got. Now this can be further decomposed into R2 plus 2CO2, isn't it? And plus 2 electrons are there. This is our R. See, these are symmetrical alkane. We got a symmetrical alkane. So this is in particular what we get through Kolbe's electrolysis, alkane. Okay. And since you can see that it is RR, so it's very clear that methane cannot be prepared from this method because 2 carbon atoms need to be there, at least 2. Okay, so it is clear that methane cannot be prepared. We can prepare ethane and higher alkanes, but not methane. Alright, this is the final equation. RCOONA decompose into RCOO negative carboxylate ion, sodium ion, and H2O will decompose into H positive, OH negative. At anode, 2 carboxylate ions will give 2 electrons. From this, we will get an alkane with even number of carbon atoms. Okay, methane cannot be prepared, propane cannot be prepared, pentane cannot be prepared, like that, heptane cannot be prepared. Okay, and we will get 2 carbon dioxide. That is not very important, like our main product is the alkane. And then at the cathode, hydrogen ion will take 2 electrons, form hydrogen gas, then evolve. This is the whole mechanism, how it's done. You can take a screenshot if you want. That's it. It was simple, it was very important. And in 11th class also, as well as in 12th class, if you have studied aldehydes, ketones, and carboxylic acid, it is a process of decarboxylations in which we get an alkane from carboxylic acid.